Alright, hi guys, we're on to the next lesson, lesson 1-6, where we're solving a linear systems of equations or systems of inequalities. Today we're going to focus on equations though, alright? Inequalities are similar, but we will focus on that in the next video. Alright, so first, a system of linear equations, you need to know the definitions, which are that it's a set of two or more equations that use the same variables, right? So instead of being one linear equation, it's two, and they both have an x and a y, right? So this is a system. So you're going to learn how to solve them algebraically. We learned how to solve them with a graph before, so now we're going to solve them algebraically, which is a lot faster because then you don't have to graph all that, right? And hopefully you can see that these are both lines. If I rearrange the variables, you can see that you can put them in slope-intercept form, right? Or they're already in standard form, if you remember that. So here's the same system, excuse my typo, x plus 2y equals 3 and x minus 2y equals 4. We're going to solve them by elimination and substitution, and hopefully this should bring back some memories of how to do it. So elimination is when you can cancel one out by adding the two systems. So x plus 2y equals 3, x minus 2y equals 4. This is the easiest way to solve this one right now because I can see I can cancel things out, right? If I'm adding these two together, right away I can see that this goes away because plus 2y minus 2y is 0, so that's nothing. So now let's just add what we've got. X plus x is 2x, and that's gone, so I don't need to write anything. And 3 plus 4 is 7. So now I can solve for x by dividing by 2, and x equals 7 halves, right, which is the same as 3.5. Either of those is correct. Okay, so now how would you use substitution to solve it? Well, for substitution, we're going to rearrange one of these. Let's just do the top one to solve for one variable. So let's solve it for x because I can see that that's a little bit easier right now. So if I subtract 2y from each side, I end up with x equals 3 minus 2y, right? Because this goes away. And now that I know what x equals, I can take this piece and substitute it into the other one. So I have x minus 2y equals 4. That's the other equation. Now instead of writing x, I'm going to substitute this in. 3 minus 2y. Now I'm just going to write the rest. Minus 2y equals 4. Okay, now let's solve that. We end up with 3 minus 2y equals 4, which becomes 3 minus 4y equals 4. Move that 3 over. I have minus 4y equals 1, and y equals negative 1/4. I realize I only solved part of the equation here, but we'll go back. So now when I plug that in here, I can figure out what x is, so let's substitute that back in. And x equals 3 minus 2 times minus 1/4. I'm just plugging that in for y, which means x equals minus 2 times negative 1/4. So that ends up being positive 2/4. It's just a half, and 3 plus a half is 3.5, which is what we got here. So that's how we know that matches. So our answers to this system is x is 3.5 and y is negative 1/4. For this one, I forgot to come back up and solve for y. But if we plug 3.5 in for x, we're going to get the same thing, right? So if we plug in 3.5, let's use this top one, plus 2 times y equals 3. I get 2y equals negative 0.5. Divide by 2. Okay, well, what's a half divided by 2? It's a negative 1/4, right? It's 1/4. So you can see no matter which way you choose to solve it, by eliminating a variable or substituting in a variable, you're going to get the same answer. Sometimes this way is quicker if it's already set up like that, right? This one always works, but sometimes can take longer. And really, this should be a review from Algebra 1. You should have solved systems of equations in Algebra 1. If we didn't, I have to pause because it's going to make the rest of it a lot harder. So let's go to the next example. And so the reason we reviewed that is because what we're adding to our tool belt in Algebra 2 is how to solve a system when there's 3 equations and 3 variables. So one rule you should know is that in order to solve a system, you can only solve for as many variables as there are equations. So if there's 2 equations, like in the last problem, you can only solve for 2 variables. Here there's 3 equations, so we can solve for 3 variables. And you can see we have an x and a y and a z. So what we're going to do is, I'm going to break this down step by step. And these steps always work, but they're hard to just read. You have to see how they apply. So step 1, start with 1. Here's with purple. Step 1 is to add any 2 equations. That's my abbreviation for equations. To eliminate 1 variable. So the idea here is we want to eliminate 1 variable. So I'm going to look at these 3 equations and see if any are set up to help me eliminate 1 variable. I can already kind of see that this first one, 2x plus y minus z, and then negative x plus 2y plus z, if I add those, I'm going to eliminate the z. So that's what I'm going to do. So let's go ahead. I'm going to label this equation A, B, C. So my choice here is going to be to add or combine A and B. So that's my note over there. So let's do that. So I'm just going to label this A. 2x plus y minus z equals negative 10. We're going to combine it with B, which is negative x plus 2y plus z equals 3. So now when I combine, one thing I can do already is just cross these out. Those cancel out and go away. Now let's deal with the rest. 2x minus x, that's x. Y plus 2y, that's 3y. And then equals negative 10 plus 3 is negative 7. All right, so I'm done with step 1. Step 2 is to add another pair of equations to eliminate the same variable. So what does that mean? I want to eliminate the same variable I did in step 1, so I want to eliminate z, but I need to combine 2 other equations besides a and b. So that means I can combine a and c, or I can combine b and c. So looking at those, I know I want to eliminate the z, so it doesn't matter really what you pick. I'm just going to pick b and c. I'm going to go with the bottom 2, okay? So let's write them down. So b is negative x plus 2y plus z equals 3, and c is x plus 2y plus 3z equals 13. Okay, so I want to combine these to eliminate z. I'm noticing right now that if I combine these, z plus 3z is going to give me 4z. I'm not going to get rid of it. But I know one of my rules is I can multiply either of these equations. Seeing that sun come in, it's leaving a glare. Let me try to scoot over. I can multiply any of these equations by any number because it's like multiplying by 1, right? And it doesn't change the value of the equation. Ugh, sorry guys. Get to deal with me in my room here. Maybe moving out of the sun will be better, not into it. Get away from the window. There we go. Okay, so there's my B and C. And I'm noticing to get rid of this z, if this was a negative 3, it would work. So I'm going to multiply this whole thing times negative 3. So I'm going to rewrite that over here. Negative 3 times negative x becomes 3x. Negative 3 times positive 2y becomes negative 6y. Negative 3, that becomes negative 3z, which is what we wanted, equals negative 9. My bottom equation is going to stay the same. Now let's combine them. Right away I know that goes away. It's what I wanted to. So 3x plus x is 4x. Negative 6y plus 2y is minus 4y. And negative 9 plus 13 is 4. Okay, so that is what I'm left with after step 2. Step 3. Take the solutions of the last 2 steps and combine them to solve for another variable. So here's what I mean by that. Let's take this one from step 1, x plus 3y equals negative 7. Let's take this from step 2, 4x minus 4y equals 4. And we are going to combine them to solve for a variable. So I'm going to pretty much do what I did up here, right? So if I look at this, I can quickly see I can get rid of this x, eliminate this x, if I multiply this whole thing by negative 4. Because then I would end up with negative 4x, 3y times negative 4 is minus 12y, negative 4 times negative 7 is positive 28. This stays the same. So now when I combine them, that goes away. Negative 12y minus 4y is negative 16y equals 32. Now I can solve for y. Divide by negative 16, y equals negative 2. All right, I've already solved for one variable. Now I just need to figure out what x and z are, okay? So here's step 4. Plug in the solved variable into an equation from, here I'll write it like this, with only 2 variables, and solve. So what that means is now that I know that y equals negative 2, I can come back and plug it into either this one from step 2 or this final equation from step 1, and I can plug in my value for y, substitute it in, and then I can solve for x. So I'm just going to pick, I'll just pick this second one, right? So that was 4x minus 4y equals 4. Doesn't matter which one you pick, you could pick either. But now I'm going to plug in y as negative 2. So 4x minus 4 times negative 2 equals 4. That means 4x plus 8 equals 4. Subtract 8, subtract 8. 4x equals negative 4. Divide by 4, divide by 4. X equals negative 1. We solved for x. We only have one variable left. So the last step is to solve for the third variable. So I'm going to open my notebook and solve for the third variable over here. So step 5 is solve for the last variable. So I already know that y equals negative 2, x equals negative 1. So what does z equal, right? So I am just going to pick any equation from the system. I'm going to pick A, 2x plus y minus z equals negative 10. So let's write that here. 2x plus y minus z equals negative 10. Well, let's substitute things in. 2 times negative 1 plus negative 2 minus z equals negative 10. That is negative 2 minus 2 minus z equals negative 10. That's minus 4 minus z equals negative 10. Add 4, negative z equals minus 6, which means z equals 6. So I can come back up here and plug that in. There's my answer for all 3 variables. So you're really taking that process of solving for 2 variables, and it just takes a little longer. Okay, so this is the traditional way to solve it, but we're going to learn a faster way with matrices next in one of our next lessons. So what we're going to do now is set up a matrix. You're not going to have to solve with it. I just want to show you how to set it up, which is pretty easy. Okay, so a matrix is a rectangular array of values. there's two types of matrices. There's a coefficient matrix, which shows all the coefficients in a system of equations, and then there's an augmented matrix, which shows all the coefficients and constants. So if you have to create a matrix of your system of linear equations, the first step you have to do is change everything to standard form, which, if you don't remember, standard form is this: ax plus by equals c. So I'm looking at these and I can see none of them are arranged. Really, you just want to get the x's and the y's on the same side of the equation. So if I deal with this first one, all I really need to do is move this 2x over, and then it'll be right. It'll be 2x plus 3y equals 1. Okay, that's standard form. Let's move my other one around. Okay, if I move this y over, it will also be in standard form. So there, now I have them in standard form. So now let's make the coefficient matrix. So all that is we're gonna take these coefficients from these two systems and put them in a rectangle. So I'm gonna label this coefficient matrix so you guys can see. There's two coefficients in each one, so it's going to be a 2 by 2, right? So A and B would be my first two, so 2 and 3. And then my second two coefficients are 4 and negative 2, so 4 and negative 2. That's how you set up a coefficient matrix. I don't think that's too tricky. And then if you had to make the augmented matrix from it, you just include these constants at the end. So I'll show you how that looks. So an augmented matrix is you take the same coefficients, so 2, 3, 4, minus 2, and then there's kind of a dashed line, and then the coefficients are on the other side, so 1 and 10. The 1 lines up here, the 10 lines up there, right? 2, 3, 1, 2, 3, 1, 4, negative 2, 10, 4, negative 2, 10. Okay, so setting up the matrices is not the hard part. We'll work with them in another video. See you next time.